Alright, so we have looked at adding, subtracting, and multiplying polynomials in our Arithmetic with Polynomials section. But now the question is saying, prove that dividing a polynomial by a polynomial does not always produce another polynomial. If you recall, I mentioned that for adding, subtracting, and multiplying polynomials, the result is always another polynomial. But it seems like for division, it's not always the case, and we have to prove that that's not always the case. And I've just got a little tip here. The question is asking us to prove that something isn't true. And you can prove that something isn't true by giving a counterexample that breaks the statement. You don't have to write a complicated proof, you just need to give one example where this statement is incorrect. So we have to give an example where one polynomial divided by another polynomial is not resulting in a polynomial. So you can have a little think about this, but I'm going to give one that comes straight to my mind. You define a polynomial and another polynomial. Oh, whoops, they should have different names. So we'll call p of x and q of x. I'm going to call p of x 1 and q of x x. These are both very simple polynomials, and in fact, when you're doing these sorts of proofs by giving an example, try to pick the simplest example you can think of. It will usually be easier to check, and there's usually something really straightforward that you can use as an example. So I'm going to do p of x divided by q of x. So we know that we're talking about division, so we have to show that one divided by the other is not a polynomial. So p of x is 1 and q of x is x. Now that's the same as x to the power of negative 1. So I'm going to call this f of x. And that's really all I needed to show. I'm just going to write out an answer in words, but what I've shown is that p divided by q, both of which were polynomials, has ended up with a function where x is to the power of negative 1, which by definition, if we recall, is not a polynomial. So we can just say, so prove that the dividing a polynomial is not another polynomial. So for example, p and q are both polynomials above, but p divided by q is equal to x to the power of negative 1, which is not a polynomial. So we can say, therefore, done. So I've just written a little sentence to go with what I've done in the working, and that should be a very valid proof because we've just shown a counterexample where this statement is broken.